Continuing in section 7.2, going to work example 2. Example 2 is we need to integrate cosine to the fifth of x dx. And notice here that we don't have sine times cosine. And so it may be a little confusing. I mean, before, when we had sine and cosine both in the equation, it was pretty straightforward that we had a function and its derivative, because really we're trying to get over to using something that looks a little bit like u substitution, some function of u times du, and then we're going to integrate that. So how are we going to deal with this? Once again, we're going to use the trig identities, and once you see how it's done, it's basically a simple trick, and that is we're going to bust this up. This is still odd. We can bust this thing up to look something more like this. It takes a while to write out. That's certainly fair. And we can rewrite these cosines in terms of sine. 1 minus sine squared of x. And there's two of them here, these things, so we'll just square that. And that works. That takes care of these. And then we get times cosine of x, that's still there, dx. And now we can say, well, look, u is equal to sine of x, du is equal to cosine of x, and we can rewrite this term with u substitution, and we get 1 minus u squared, quantity squared, times du, and we can then integrate this. But we're first going to need to FOIL this out, this term out here. So let me do that real quick, and then we get 1 minus 2u squared plus u to the fourth du. And then now we can integrate very easily, and we get u minus 2 times u to the third divided by 3 plus u to the fifth divided by 5 plus c, and all we're left with now is resubstituting back in. U is equal to sine x, so we get sine of x minus 2/3 sine cubed x plus sine to the fifth x divided by 5 plus c. And that should be our answer.